Okay, we have a MacBook Pro. This is an A1990, and this is coming in for the USB ports not working. So the device charges fine. However, the machine does not read USB devices, so it charges across all the ports. The client said it charges, as you can see that it's connected, and then the other port also connected. Let's see that on the right side, that's also connected, and the other one. Now across all the four ports, the device charges okay, but the complaint is that the device does not read USB. So I asked the client if they try using because the ports on these machines are USB Type-C. I asked if after they try using an adapter as well as trying to use a direct Type-C cable to the external drive that they are trying to power, and they said they did. So what we are going to do is we are now going to check with our own. So we have an adapter here. We are going to use this adapter, and then we also have a direct USB-C to USB-C cable to use, and yeah, we will see how this behaves. Now, basically, before we continue, in terms of when you are fixing a USB port issue, there are two issues that you're most likely going to face. Now, issue A will be that the device will power the USB device, however, it will not read data. Now, the way you identify that is, say, for example, if I connect, okay, so let me connect my, so I'm going to connect, I'm going to connect cable. This cable is coming from my machine here. I'm going to connect it to this device. So when I connect it, you see the light. So obviously I have a prompt asking me to accept. So I'm just going to accept that. Now you can see there is LED on my. Now the blinking of the LEDs means that the device is initializing. However, I'm not interested in the blinking of the LED. You see the LED that is standby. Okay, now it's blinking again. It's trying to read the device. Now, when the LED is standby, or when you have any form of LED at all, that will tell you that the device itself has power. Now, if you do not see the content of the USB drive or the USB device on your device, it means that the device is powered, but there is no data across. So there are two issues that you probably run into when it comes to a USB device's repair. You will have an issue whereby the device is powered but there is no data, and then one of the ways you can confirm that is if you can actually see any form of indication that the device is getting power but there will be no data. And then you have another issue whereby the device will have no power at all. So these are the two issues that you probably run across when you're having issues with your USB repair. So we are going to eject our drive because that's the same drive we're going to use here. So these are the list of drives that's connected. So okay, now drive is ejected. So now what you want to do, first thing first, we want to try to use a USB-C to USB-C cable on the device to see if that will work. So we'll connect, and also the client mentioned that it doesn't matter what port, that across the four ports that the USB it's not working. So that is connected. Let's see if we have okay, so we have power. We have power, but we don't have data. We have power, but we do not have data. I don't know if you see that. Yeah, so that indicates. And the other side, yeah. The other side also there is light as well. Yeah. So you see, we have power, but we don't have data. So what that means is the device is powered, but there's nothing that the machine does not identify or detect that there is an external device connected to the machine. So what we want to do is we want to go to disk utility, and because the reason why I'm doing that is sometimes it may be that the drive or the connected device is not in the format that your operating system will read. But you will see, so if we go to the disk utility, we should be able to see it if the drive is not in the format that the operating system will read. Now, so on disk utility, we can go to, okay, we are on show all drives. I'm just trying to increase the brightness again so you guys can see that. So we are now on disk utility, and then as you can clearly see, we only have the internals and we don't have anything on the external. So even when I click on show all drives, you see that we don't have anything on the external. So now so it means that the issue that we're having now, it's an issue of data and not the issue of power. Now the reason why that is important is this. So if I'm just going to quickly go to the board view of this is an A1990. Let's quickly go to the board view. Now this is the board view of your A1990, and the board number is 820-01041. That's the board number for your A1990. Now the reason why that is important is this. If we go to if we go to L3500, so L3500, let's quickly go to the schematic here. Let's type L3500. Now, L3500, see where it says here that it's the Thunderbolt TBT 5-volt regulator IC. This is the page for your 5-volt regulator. Now, this 5-volt regulator, it's what is required for your USB devices. Now, this guy here, so if we have power on the device, but we don't have data, then we are not going to worry about, then it would mean that we have 5-volt here. If we have power on the device, correct, but we are not able to read it, it means we have 5-volt here. Now, then the only thing we are going to now worry about is we are going to look at the data line of our USB. So if we didn't have any type of power indication on the drive, then it will mean that we do not have 5-volt coming out from our U3500. Now, the fact that we have 5-volt, the fact that we have power on our drive, it means that U3500 is at least doing its job. So what we are now going to do, which will mean that we're having 5-volt from U3500. Now, what we are now going to do is we're going to take the board out to basically look at the data line of the USB circuitry, and then we'll take it off from there. So let's quickly take the board out. The machine is actually also doing something a bit funny, which is when it goes to sleep, it doesn't seem to wake up. That's a different issue. But then the client didn't mention that. The client only mentioned the part of the USB is not working. So the client did not mention this issue here. But this is an issue. I mean, usually when you have an issue whereby the device does not wake, you want to go have a look at this section of the board here. Okay, this section of the board here, J4800, this guy here. So there are two of this. There should be two of that on the board. So you have one on the right and one on the left. So let's go to J4800. Let's type that. J4800. So you see what you say is SMC lead left. SMC lead left. There should be two of that. You should have another one on the right. So now, so basically, you see what it sends out. It sends out LED lead open left, lead open left. So, so when you close the lead and then you lift the lead open, that signal should be high to tell the device that the lead is what is now open, which will now wake the device. Now, the fact that when we close it, it did not wake, it's an issue. And also, and another thing is actually very funny, because also when the lead, okay, let's leave that. So there are two of it, so that I don't lost you guys. So there should be two of it. Here you have left. You should also have another one that says right. So there's one on the left, and there should be another one on the right, which is this guy here. Yeah, so it's going to be J4801. J4801. So let's quickly type that. J4801. So that is going to be a what? That says left. J4801. Should be the one that says right. No, yeah. Okay, here you go. So here you go. SMC lead, right. So there you go. Oh yeah. Okay, so, oh, okay. So both are actually, wait, did we see both on the same page before? No. Okay, for some reason we haven't, okay, yeah. So we haven't both on the same page. So I was a bit confused. Why do we have both on the same page? But then another thing we do see, however, it's both are being fed from the same source. You see that? U4802 feeds both. That's it. Let's have a quick understanding of it. So you have this is a logic gate. U4802 pin 2 on U4802. Okay, you have R4804 will basically, okay, will input, and then the input of that for the board that says, okay, NC is not connected, and then eventually U4802 does the output. Okay, so we have two of it on the board. We have G4800 and then you have G4801. So when the device, when you leave the device, you should get that signal to tell you the signal should be high. So when you close it, the signal will be low. For example, if what I mean by the signal being low, it's say for example, if you have 3.3 volt on that signal when the device is when the LED is open, that's what you have. But when you close it, that signal should drop, which would then allow the device, the screen, to basically go to sleep. But for some reason, like I said, we see even when we open the device, we don't see. So here, I don't know if you can see my caps lock. My caps lock is on. The device is still on, but it does, for some reason, it doesn't detect that the screen has been lifted. So that's something else. Sometimes you might have. So this is a very crazy thing. When that section of the board is actually affected, this section, the delete sensor, when that is affected, the power button doesn't work. It's crazy. I mean, so it's just crazy. When that doesn't work, the power button also doesn't work. It's just, it's just crazy. So yeah, let's quickly, so what the reason why I actually mentioned that was sometimes you might have, issue A that presents itself in one way, but then is the cause of something else not working. For example, your SMC, your lead sensor not working prevents your power button from not working. So that is something that I have seen, and that's basically how that works. Now, but in terms of the USB ports not working, I'm not sure if that is in any way connected to it. Now the device decides that, and then you get a crash report. So I'm not sure if that is connected to it in any way, but we will see when we open the device to see what is it that we are dealing with. Okay, let's quickly flip the device and take out the back plate. So we are going to use a pentalobe screwdriver, which is a P5, and I suppose the two here are going to be longer, and they are going to be the same. The ones that goes directly into by the hinges, they are going to be longer, and they are going to be of the same sizes, and then the ones at the bottom here are also going to be on the same sizes. So we're going to start from the right here. Let's screw into, okay, I need another screw for that. I'm not sure like that. That's a different screw. Yeah, that's a different screw. We're just gonna make sure we get another one for it. Okay, so to open this, there's an opening which is you have your vent, your cutoff for your vent here. So you can either use a suction cup to basically do a lift, and sometimes you may want to basically stick a small tool in here to basically do the lifting as well. But I don't do that. I just use my fingers to do the lifting on the side. I mean, that helps me get a bit of a grip, and then I can click. Okay, that's out. So what I want to do is I want to make sure that my screws are on basically in one place, and then here we see it. So the device has been opened before. Most of the screws are not present. We're not sure what has happened here. Most of the cowlings are missing. Most of the screws are also missing. Both hinge connectors are missing. There are only 2 screws holding this the screen connector. So most of the screws are missing. I'm not sure what has happened here. That's missing. That the cowling there is missing. That is missing. Even the battery board screws are missing. Okay. That's really strange. I'm not sure. Okay, yeah, that is missing. That cowling is missing. The cowling here is also missing. So we're not sure what has happened here. The cowling here is missing as well. You have the screws here that are missing. Even the antenna module screws are missing. Okay. Interesting. Anyway, we just want to tackle the issue while we're here. So let us, the mic clip, it's broken off, it's not present. That is the clip for the mic, that is not present. Okay. First thing first, we are only going to worry about while we're here. First thing first, I mean, we will report to the client to inform the client about the state of the device inside. So first thing first, let us, and then by the way, all of what you've seen so far will not play a role in the USB port not working. All of what you've seen so far is not going to play a role in the USB port not working. So let's now disconnect our battery, which is going to be the first thing you do once you want to work on the device. Once the backplate is out, you want to disconnect the battery. Now this device here has 2 battery management. You have the BMU, cable, which is this guy here. I'm going to disconnect it. Now you see, once I disconnected it, now the machine is off. And then you also have the main battery power line, which is the main voltage line 2, and from the battery. Now that it's put in place using a screw. So now with the cable disconnected, as you can see, the data cable disconnected, it stops the flow of power from the battery to the board. So that alone is fine, but because we are obviously going to take the board out, so we are just going to start by taking the screws out. So for this, we are going to start by using a T5. We'll be needing a T5, a T4, and a T6. So let's start with the T5 screws. Most of the screws, as we know, are not present. Now that is the screw that goes there is supposed to be a T4, T3 screw, but then they use this screw that they use is for, usually it's for MacBook Pro, the M1s, or the MacBook. So I mean, that is not supposed to be for the machine, but yeah, I mean, most of the screws are not present anyway. Now that screw is a bit longer for it to be in that spot. So this screw is going to be the one that goes in this section here. So that is not supposed to be there. I mean, again, most of the screws are not present anyway. So you see, the person that did this really doesn't know what they're doing. So you see, that screw, the screw here is supposed to be the one on the right, not on the left, because of the screw that goes into it, which is, yeah. So I mean, the person who did this, they just, yeah, I would say they don't know what they're doing. I mean, if they knew what they were doing, I mean, to start with, all of the screws will be present, and they will place the screws where they should be. But nah, I would say they don't know what they're doing. Okay, a T5. Let me grab my T5. Oh, my T4. Did you finish the battery installations? You tested it? Okay. Okay. Okay, now we want to use our T8 or T10, whatever works for you. Now we're taking the cables out. We use a tweezer to help us lift the antenna cables from the board. Now with this one, it has an equal opening, right and left. It doesn't really matter where you take the board out from. You can either do it from the right or from the left. So, but then even while you're doing that, make sure all of the cables. Now, I think for this one, I think it will be safer to do it from the right. The reason being because of the touch ID, it's on the right. So if you do it from the left, chances are that the board could hook onto the touch ID could stick on the board, and then that might break it. But that's very rare. But just to be safe, you can do it from the right, so that way the touch ID is out of the way. But even with that, you also want to make sure that you're still careful and you don't want to rip out any cable. For example, if you rip out the touch bar cable, that is a problem. I mean, depending on which one you rip out. If you rip out this one here, it's still fine. But if you rip out that one, then it's a problem. If you rip out this one, that's fine. But if you rip out that one, then it's a problem, because the touch bar has two configuration. You have the one that does the display of what you see on the screen display, the information that you see here. So there are two cables. The information that you see here, one will do the feeding of the information that you see there, and then the other will do the touch, the response of the touch. So for example, you might have a situation whereby you have information here, you can see that the lead is on, but it does not respond to touch. So, and you might also have a situation sometimes whereby the touch is active, but the lead is not on the screen. So there are two cables there, so one controls one and the other one controls the other. So I'm just going to show you guys what I mean by that, and let's quickly go to the board view. Now on the board view, these are the two connections for the touch bar. So you have J5110 and you have J5100. So if I click on J5100, you see what it tells me: TP_DFL_ touch panel detect. So you have DFL LED open. So okay, I'm not going to go over what all of that is. So so this is the touch. So basically the touching that you do. So that is the one. That's where it connects to the board, and then the other one, that's going to be the information that you basically the information that you get on the board, the information on the panel, then it's going to be on this guy here. So what will happen is, if you can have the situation whereby the touch bar LED is on, but there's nothing going through when you basically touch it. Okay, so that is that. So the board is out. What we are now going to do is that we are going to inspect the board. General inspection before we focus on the concept of the touch, the USB port not working. So let's see, on the right, what do we see? The board looks clean. Yeah, it looks fairly clean. Nothing stands out. Nothing stands out. Okay, so since we don't see anything that stands out, we are now going to shift. So two things we are going to worry about. So first thing we're going to start with is to check the USB circuitry, which is this guy here, USB circuitry on the other side. L3500. So that's where we're going to start from. L3500. Let's see what's happening there. Okay, so L3500, that's the output inductor. We are now going to see what U3500 look like. It's here and search for U3500. U3500. Okay, that's U3500. So let's see what U3500 looks like. So I'm just gonna. So U3500 is on the other side of the board, so which is going to be on this side of the board here, and this is U3500. This guy here, that's U3500. This one here. So that is U3500. So we are going to connect and then check it out to see what is happening. Who is calling? Unique. Okay, you can let me answer him. Okay, so actually what I saw, see here, there's a bit of liquid here in this section of the board. Let's see if you can see that. See that? Can you see? See that? That's liquid. And also there's been previous work on the board there. There's been an inductor replaced, but that really doesn't have anything to do with the issue that we have at hand. I suppose that was when the device, yeah, I suppose that was the type of repair they did before. So so our issue, it's we are going to have, our issue is going to be centered around we're going to be looking extensively at U3500 as well as U3000. So U3500 and U3000. So first, let us start with U3500. But because we have power on our device, most likely that's not going to be our issue. But nonetheless, let's check that out. So we have our USB port connected. So let's put power to the board. So first and first, let's see if we have 5 volt. Now we are going to be checking for 5 volt on L3500, but most likely that is definitely going to be there because we had power onto the USB device. So we have our black probe on ground, and then our red probe is going to be on the inductor. This is so the L. So whenever you see L, that's for your inductor. Whenever you see L, that is an inductor. So that is what you're going to measure, and that is this guy here. So we have our black probe, this one here. That's the inductor. So black probe on ground, and then red probe. Let's see what we have. Is that okay? So before, let's confirm, do we have voltage on the board at least? So at 12.6. Okay, we have voltage on the board. Let's see, and then this 0 volt. Okay, but there's something else. Another thing that happens is some of the USB port design, they are not always on. So what that will mean is we'll get 0 volt now, but when it detects a USB device connected, then 5 volt comes on. So let us connect a USB device to it. The older design, you have the rail always open, but in newer design, so what will happen is that the rail will be closed until you connect an external device, then the rail will be open. So now let's see if we have 5 volt on that line. So now we have 5 volt. So if we disconnect, if there is nothing on it, then the rail will be closed. So without it being there, then the rail will be closed. If we measure, we should have 0 volt. It's actually going to drop. Yeah, it's going to keep dropping. It's going to keep dropping. Yeah. So, but once we have a device connected, so what will happen is the rail will now become active. So now we should have 5 volt. Okay, that's 5.2. Now, so the thing is this, yeah, the fact that so two things we're going to do. First, we can see if we have if the device itself is if the chip is overheating. We don't see that. Okay, 1 minute. Manga, I'm going to. Okay, Ross, sorry, Ross. No worries, Ross. Okay. So, and that one, I go look into them, bros.
Check out because I don't know.
No worry, I go look into them, bros. No worry, bros. Okay, bros.
It's free. Don't forget that.
No worry, bros.
Check them out.
No worry, bros.
All right.
Okay. Okay, so so that information is important. So sometimes you might say, okay, but I see that I'm supposed to get 5 volt here. How come I'm not getting 5 volt? You have to understand that some of the circuitries, the way they are designed. For example, this one, it needs so the USB device itself needs to be present before you get a 5 volt there. So imagine if you didn't know that information and you just assume, oh, I don't have 5 volt and I have a problem, and then you just go ahead replacing it. That's not going to solve your problem. And remember what we said: the fact that we had, if there was no 5 volt on that line, there was no way we will have LED on the connected device. Okay, so now because of, so we are just going to go ahead and do one thing, which is to address the data line, which is basically going to be a filter on that line. I'm going to show you guys something. So on U3500, let's go back to U3500. U3500 is going to do one thing. Now, U3500 is basically going to be the guy that regulates or produces the 5 volt that powers the USB-C, that powers the USB, the USB devices. So you see where it says the output is 5.2. You saw that we actually got 5.2, yeah. So that is, and that is doing its job. That's doing its job. So we are not going to really worry about U3500. What you want to go to, it's going to be U3000, correct? Yeah, because we have 5 volt. We have our 5 volt, so we're not going to worry about that. Let's go to U3000. Let's see what U3000. So on U3000, yeah, so this is U3000. This, what am I doing? Okay, so this is U3000. This is what we want to worry about. What am I doing? This is what we want to worry about. L300, L3000. We want to see what's happening by L3000. Yes? So we want to see what's happening on L3000 because that is the information that feeds to and from your PCH. You see USB 2, UPC, XAP, and then XAP. So that's the data line that we're going to be interested in. So we should have, let me see. So that is what we are going to be interested in. So what we are going to do now to basically save our time is let's go to L3000 to see what that is looking like. Now L3000, because remember we have power to the device. What we don't have is data. Yes. So what we want to do is you see most of the lines that they are bidirectional lines. But what we want to be interested in is this filter here, which is L3000. Let's see what is happening there. Now, on previous design, this fails very easy. I'm just going to quickly pull up a previous design, which is a common board would be 80-3115, which is the 2012-2011. Let's quickly pull up a 3115 board. 3115 board. 820-3115. This is an 81278 from 2012. So 2012 because so now on this board here, the USB ports, here. Okay, that's a FireWire port. What is that? That's your Ethernet. That's your USB. Now on this one here, this one, the 5-volt is always on. So whether the port is on or off, whether you have anything connected or not, is always on. Now usually what fails on this is the data here, is the data line, which is, you see the one that says L4710, and that's also going to be like a filter, L4710. So that is the same thing that we are going to look into here. That's the same thing that we are going to look into here, L3000, to see if that is in good condition. So usually the way that fails, it's one end, this works more like a fuse, even though that's the wrong term to use. But what I'm trying to say, it's one is going to be, so one end, both, so it usually will have 4 ends. So here, for example, you have 1, so you have 1, 2, and then you have another 1 and another 2. Now one end, so one end will feed to the end of the USB, the USB port itself, you see, pin 3, for example, I will show you now. So you see pin 3 feeds to, this is the USB port itself, and then you have another one, also feeds to the USB port. Now, then pin 4 is going to take that information to your PCH, correct? And then pin 1 is also going to take the information to where? To your PCH. So what basically happens is, so that inductor, it's basically will be a mediator between your PCH and the external and the port itself. Do you understand? So when it usually, what happens, it breaks. So the way it breaks is, on this side, over time it lifts from the board. So over time, you have it suffers a dry joint, and as a result, it's no longer acting as a bridge between between your PCH and the port. So that's how it fails. So usually what we'll do is we replace this and then it works again. So I'm hoping that is, and then again, the only reason why you would do that also again is you have to make sure that there is actually power, which is you have 5-volt, and what you don't have is there is no data. So that's the same thing that we're going to use here now. So let's quickly go and replace L3000, which is this guy, and hope that fixes our problem. So first of all, let's identify where is L3000 on the board. Let's quickly switch back to our 15 inches. Search L3000, L3000. So this, you see, L3000, you see the same form factor that we saw, correct? That's exactly the same thing that we see now. So you see that there is going to be to the USB, and that is going to feed to the PCH. The same thing, yeah. And then if you go to the other side, just the same thing, that as well, that will also feed to your PCH, just like the same way that one is configured. Yes. Now, which would then mean that if you, because of the way, which would then mean that you can actually use the inductor, that same filter from 2012 here, and it's going to work because it's practically the same design. So let's quickly identify that, and that is going to be this guy here. Where's, yeah, this guy here, this one here, this one, you see that? This, you don't see it, I'm pointing to it, this, can you see it? So that's the inductor. So that one, so you can use that. So what we can do is we can check the state of it by measuring on both sides to see. So both sides should obviously there should be reading across it. It shouldn't be OL, it should not be open line. But because of time, we're just going to go ahead and replace it and see if that solves our problem. But again, usually what you want to do is you want to actually read it to see what you're getting, so you don't just go ahead and replace it. And again, for we're only doing this because we have voltage on the device itself has voltage, the external device has voltage. The only problem we have is data. Okay, let's get another board. Okay, that's it in its place. So we are quickly going to now test to see. So we are kind of turning our brain off here because, like I said, we are supposed to see what it's giving, what the filter is giving us, but we really not because of time. So we just quickly replacing that. And then again, I said another thing I'm saying is the reason why we are even there in the first place is because we have 5 volt from our U3500. If we didn't have 5 volt on our U3500, we would not be busy with our U3000. So now let's see if we have any changes. If we have any changes, the USB port, the USB device should be blinking, which is basically initializing if we have any changes. So let's see. The device is not on yet, still waiting for it to come on. Okay, now the device is on. The light is stable. It's not blinking as yet. Okay, now it is blinking. I don't know if you guys can see that. It did blink, so that's a good sign because it meant that the device actually tried to read. So what we're now going to do is we're now going to disconnect power and quickly put it in the shell to see if we now have a working USB. And then something. Okay, but let's quickly test that. Let's the reason why we not being very detailed is obviously because Shai needs to be somewhere, so we have to be quick with that. So you see the difference between the first time and the second time. The first time there was no blinking, you saw that, it was just yeah. Okay, so we're just going to connect minimal cables again because of time, just to get the device just to see if we have USB working. And actually, we don't even have to wait for the device to boot up. We can just hold on the Alt key and see if it reads the USB. Yeah, so that also saves us time from waiting for it to boot. Because you need to leave as soon as possible. Otherwise, sure, Sophia is gonna kill me. I know I'm gonna die. I know. Okay. It's connected. Let's quickly hold down the Alt key. The charger is going to automatically start the device. So I'm not going to press the power button. So to see, yes, we have power on the trackpad. The device is starting. Moving on the Alt key. Let's see if we have. Let's hope that we have working USB. That's it. We have working USB. So yes, guys. Thank you, guys. Sorry we cannot go in depth to describe or to explain, but just a quick summary. So how we arrived at L3000, we basically had to use the same setup from previous designs, which is the 2012. The standard aids, there are two, when you're troubleshooting your USB issues, there are two things to look out for. If you have data, if you have power, but no data, you want to look at the data, the data section of it, which basically the USB itself and the PCH. You understand? And usually you will have a filter in place of that, which is, for example, in this case, you have L3000. The reason why we're here is because we have data. But if we didn't have, because we have power on the device. But if we didn't have power, we will not be here. Rather, we will be by U3500, correct? We just U23. So we'll be by U3500. So we'll be by U3500 because that is the guy to give us 5 volt. And another thing to also notice this. With the older design, the 5 volt is going to be always on. With newer design, the 5 volt will depending on the type of board you have, the 5 volt will not be on until you connect the device. So once it detects the device is present, then you will get your 5 volt on your output, which is your L3500. Thank you guys. Sorry that we just have to rush this up. I will see you guys in the next one. Thank you. As you guys can see, we have working device. By the way, the reason and then the part of the device crashing, so I'm very sure it's because of the liquid that we saw in that section. That's why. But that is something that we'll have to relate to the client, and then we hear what they have to say. Thank you guys, and then I will see you guys in the next one.